Our next important function is saveVector, that saves a vector and its associated metadata into a Qdrant collection. It includes ID validation, robust error handler, and debugging message to ensure the operation is smooth and traceable. First, we declare the function with parameters ID, vector, and payload, with types string, list, and dict. We use type block to handle potential exceptions during the saving process. Validate ID calls a function to validate and format the given ID. We will write this a little bit later. Then we print the message to the console to confirm the validated ID, useful for debugging and tracking the ID being used. Next, we call the Qdrant upsert method to insert or update a vector in the MetInsights collection. This is a list of vectors to upsert. Each vector is represented as a points tract. In our case, only one vector is being used. The points tract includes ID, vector, and payload. The unique identifier for this vector is the ID. The vector brings the data itself, a list of numbers, and the metadata associated with the vector, the payload. This is descriptions, tags, and etc. At the end, we print a confirmation message if the vector is saved without errors, and we return true to indicate that the vector was successfully saved. If we have an exception, it is catched, printed, and we return false to indicate that the operation failed due to an error. Our next function is validate ID that we used above. We define the function that accepts a single parameter ID, which represents the identifier that needs validation. We again use type block to catch exceptions when attempting to convert the ID. We attempt to convert the ID into an integer using int function, and if successful, the integer is returned. Qdrant allows numeric IDs for vector points. This step ensures such IDs are correctly interpreted. If we have an exception, we begin another try block to handle the next step, interpreting ID as an UID. We attempt to convert the ID into a UID object using the UID function, and then a string before we return it. If the ID isn't a numeric, Qdrant supports UID as an alternative format. This ensures such IDs are valid and formatted correctly. If the conversion of the ID fails both integer and the UID validation, we are raising a value error with the descriptive message. The valid ID function ensures that the provided ID is either a valid integer or a UID. It tries integer conversion first, falls back to UID validation, and raises an error if neither succeeds. This ensures only a valid ID are used when interacting with the Qdrant. Additionally, I want to say one more time that this is not a production-ready code. This is a tutorial where I'm representing how to integrate an AI in applications and have AI-powered application. Here, for example, you can see try-catch pollution that in normal code or a production-ready that shouldn't happen. Try-catch pollution. And next we need to fix our imports in services that we messed up previously. We are importing NP from NumPy, save vector function that we just developed from the repository, and the UID. And we are moving to main.py. So from FastAPI library, we import FastAPI class to create the app, and HTTP exception used to raise HTTP exceptions returning 500 error if saving the vector fails. From schemas, we import item schema and response schema. Item schema and response schema. Those are our created Pydantic models. From services, we import process item function that handles the business logic of purchasing and saving the vector. Here is the process item. And from repositories, we import QdrantClient for interacting with Qdrant vector database. Next, we initialize app that creates an instance of FastAPI application, which will handle incoming HTTP requests and route them to the appropriate endpoint. We will register a get endpoint at test. This is a simple route to verify that the server is running. And that line defines the handler function for the test endpoint, and we are returning a simple JSON response indicating success. We register a post endpoint at the upload that specifies a response schema as the structure of the response. Next, we define the handler function upload item, and we are passing an item validated against the item schema model. We call the process item function, passing the item, and success indicates whether the operation succeeded. If checks if the process failed and raises an HTTP error with 500 and message failed to save vector. Otherwise, we are returning a JSON response conforming to the response schema model. Success is equal to message equal item saved successfully, and the ID is equal to item.id or generated ID. And our next endpoint is record. This is a get endpoint called records, and we are defining the handler function called get all records for retrieving records from the Qdrant collection. We are using try block to handle errors during the database query. Client scroll queries the Met Insights collection in Qdrant, and we are passing arguments like collection name equal to Met Insights that specifies the target collection, with payload equal true that retrieves the metadata along with the vectors, with vectors equal to that indicates vectors in the result, and we are limiting the number of returned records by limit equal to 100. Then we return a JSON response, success true, and record contains the retrieved records or points from the Qdrant collection, and we have accept that catches any errors during the query and returns JSON response with the error message. And at the end, we have this piece of code that ensures this code runs only when the script is executed directly. We import UVcorn, an ASCII server for running FastAPI apps. We talked about that in our previous videos. And UVcorn is used to start or run a FastAPI application. The app is our application. The host 0.0.0.0 allows the server to be accessible from any IP address. This is typically used when deploying on a remote server so that other machines can connect. And port 5000 runs the application on port 5000. So let's run our application as a module within the app package, allowing relative imports to work. Sorry, sometimes I talked a little bit too fast. And we got an errors. No module repository. Yep. Here we have an error repositories. And there's fixed. Come back and again. And voila! We have a working application. So let's test it out. I have installed QdrantClient on my Visual Studio Code. You can install it from extensions. QdrantClient, and it is this one, the first one. And we have already created a localhost 5000 upload, but let's first test our test. We have apt-get test. Let's see the result. And yes, it is working. Test 200. Okay, response. Now we can go and upload. But we have to switch also the request. Instead of get, it should be post. The data that we need to send. ID, name, description, metadata, and etc. And yep, it works perfectly fine. We are generating the vector with the send it request, and it is saved in the database. The database should be running on Docker. The Qdrant database should be running on Docker, so pretty much that is for now. And I forgot to mention actually one more thing. In the repositories we have collection matching sites. If that collection doesn't exist on the Qdrant, you may have some issues, so you have to insert it manually. Depends on your situation and your setup. I've got messages that sometimes, yeah, that should be inserted manually. And then you will get the success messages and that everything works